Thank you so much for joining in today. And we are starting soon as people start joining. So until then, let me know like how much excited you are for today's session and what do you expect from today's session. Just let me know in the chat section. And how's your day? How's your weather at your place? So from which college you are?
Meanwhile, you can let me know in which year you guys are in.
Yes. Or you can even give show some excitement by thumbs up or stating any reaction in the chat section. Or do you have any questions before the session start for our mentor or today? So you can let us know in the chat section also.
Yeah, you can let me know what are your expectations from the session or anything you wanna know about me.
Why is chat section empty today, guys? Just let me know anything like from where you are, from which college you are, or do you have any specific questions? Just write it down in the chat section while other people are joining. So we will start by 5:10 or 5:05 while other people are joining.
Guys, be interactive. It's not like just your regular class. It's just a session where you have to learn something. More about my career. So, well, I passed out my engineering in 2021, and then after that, I joined Infosys as a specialist programmer for 3 months, and then after I again started hunting for job, and then I'll end up in PhonePe, being a software engineer. In my college days, I've done a lot of competitive programming, so that really helped me to get the job at PhonePe. So like I'm having only 1 year of experience in the software engineering industry. Do you do competitive programming now too? Well, it's a good question. I really enjoys it, but right now I don't have much time to do it regularly. But yeah, when I have the time, like in a month, I do some contests so that I still have the grab on my data structures and algorithms. A hands-on project is mentioned in the webinar description. How depth do we have to know regarding sorting to complete a hands-on project? Mm, hands-on project, uh, I don't think we are going for a hands-on project or on the basis of sorting only. On the basis of only sorting, you can't complete a project. Like sorting is just an algorithm. We can definitely solve one or two problems using the sorting, but not definitely a project. Project is a big thing. Project don't lies only on a single algorithm. Uh, we will get the whole understanding of sorting in this webinar. like we will understand what actually sorting is, how it works, what are the type of sorting algorithms, how they are different from each other, how they are different in case of time complexity and space complexity, what are their major differences. So we will understand them. And if we will be left with some time, then yeah, I'll try to solve one or two problem also, or maybe we'll give you some problems.
So let's start the session. Hi.
Yeah, but one second. I guess we have one more question in the chat.
So you can see the chat session. Actually, it's empty for me. Like I cannot.
I think they are sending direct messages to me.
Oh, that's right.
Uh, okay, I think one more question here is how extent CGPA matters during the placements. Well, CGPA don't matter much. Like if you have a decent CGPA, like around 8, then you will be able to sit in placement of any company. So you don't have to shoot for 9.5 or 10 pointer. 8 is a decent CGPA, and I guess no company will like tell you that if you have 8, then you can't sit. So 8 is a very decent. So focus on CGPA only till 8 or 8.5. Like don't go for 9.5 or 10. Like it will be waste of time as per me. And doing coding in HackerRank is enough. HackerRank is a good platform to start as a beginner, but I think if you think about competitive coding, then you should go for Codeforces or CodeShare. And if you want to prepare for the interviews, then you should prepare from the Lead Code. Lead Code is like really one of the best platform that can help you in cracking the interviews. Yeah. Okay. Questions done.
Yeah. So yeah, we will take the questions at the end also. So let's start the session. Hello everyone. Thank you so much for joining in today. I am representing my ways today. My name is Nata. So with today's masterclass, we have our mentor Mayank Chaudhary. He thank you so much, Mayank, for accepting our invitation to upskill our students. So he is at, as he said that he is an SD at PhonePe, and he has much knowledge of DSA, and his skills lies in DSA. So he will teach you the topic or sorting of DSA in today's masterclass. So feel free to ask any questions, and you can also write in the chat section if you have any doubt in meanwhile. So after this, we can have the live mentor Q&A also. So feel free to ask anything, and let me know you. Let me know you. Hello, am I audible?
Yeah, yeah, you are audible.
Sorry, my neck is like
It's okay.
public. Yeah. So, and let me give you a brief introduction of my way. So, we are a career platform where we actually help students to upskill and help them to get placed. We also have a new initiative known as By Gurukul, where we are placing students and give them free training on their placement, that is job guarantee program. I will let you know about it in the end, and the most important part is it is free of cost. It does not charge anything from anybody, and let student play. So I'll let you know all after the session. So I hope you stay till end and enjoy the session. Just show some excitement in the chat box or reaction so that we can start and I can know that you are active and interested for the session. Please do let me know or do any reaction. I just eager to hear you guys also.
Yeah, guys, be interactive. Just learn something from me, and maybe I'll learn something from you. So let's start.
Yes, ma'am.
Uh,
Stage is
yeah,
yours. Thank you so much.
yeah. So I'm sharing the screen. So let me know if it is visible to you or not.
Yeah, sure.
Give me a second, like I'm changing some system preferences.
Okay, okay, sure.
I think I have to like quit and reopen the Zoom again. So give me a second. I'll change some system preferences for sharing the screen. So yeah, this Mac was not allowing this. So just give me a second. I'm rejoining it.
Okay, sure. Students, until then, just let me know that still till our mentor is coming. So just let me know. Do you have any question for my ways? Just let me know in the chat section, or right now you can unmute yourself and ask me. We will talk over it. Anyone, just let me. You can unmute yourself and talk to me. Meanwhile, our mentor is joining and starting the session.
Am I audible?
Yes, you are.
Okay, thank you. I think host disa it's showing host disabled participant screen sharing.
I have made you a co-host.
Yeah, please.
Yeah,
I guess it must be visible now.
yes.
Okay, okay, fine. So yeah, guys, let's start with the sorting webinar. First of all, I would like to know how many of you already know about the sorting or are very new to this topic. Just let me know in chat section or anywhere you can just open the mic and say what do you guys know about it, or like have you do you have any experience in this topic? So so that I can change the content as per it. No. Okay. Okay. Guys, do you know about the term data structures and algorithms? Like, it's one of the important subject. Yeah. Okay. Cool. So, as you guys know about the data structures and algorithms, so sorting is also another algorithm that is used to arrange the elements in some particular order. Okay. So, suppose I've been given uh, 10 numbers in 1D list, and you have to arrange these elements in some order. It may be increasing or it may be decreasing. Okay, so that is called the sorting algorithm. If we talk about the basic definition of sorting algorithm is basically an algorithm that is used to arrange elements in some order. So let's see. Oh, sorry. Let's see it with an example also. Suppose, suppose I've been given a list. It's a 1D list, and suppose it has 6 elements. Okay, so let's put some numbers in this list. Suppose here comes 2, here comes 1, here comes 4, then 6, then 5, and then 3. Okay, so this is the list you have been given, and you have to sort this list in some order. It may be ascending or descending. If we sort it in the ascending order, the final result will look like 1, 2, 3, 4, 5, 6. Okay, and if we sort it in the descending order, then it will be 6, 5, 4, 3, 2, 1. Okay, so it may be ascending or descending. Okay, here comes ascending, here comes the descending. So there are many ways to convert this list into the ascending order or descending order. So these are basically algorithms. All these algorithms comes under the part of sorting, which helps to sort all these numbers. And there are lot of sorting algorithms available to us. Like if I tell the names of some very popular sorting algorithms, they are like insertion sort, bubble sort, merge sort, quick sort. So these are the algorithms that we use to sort these numbers inside the computers. Okay, so this was the basic definition of sorting. Very basic idea of how sorting works. We will see some algorithms how they work. But before that, I would like to know about. I would like to know from you guys. Like, okay, it's a topic that sorting we are using, but are we going to use it in any real life scenario? Like, do you know any real life scenario where we uses the sorting on day-to-day life basis? Yeah, if you know, please mention where you have you seen like we are using the sorting algorithms in our daily lives. Any example, anywhere you uses insertion sort, playing cards. Okay, yeah, nice. We uses insertion sorting algorithm to sort the playing cards. Anything else? YouTube sorting videos based on views. Uh, yeah, okay. It does the same. Uh, where it collects the videos and then sort on the basis of views. Very nice. While purchasing in mall and payment in queue. Payment in queue. But that's not the I guess that's not the example of sorting because uh, whoever comes first uh, gets the does the payment first. So that's kind of queue example. Queue is also a data structure. We are not sorting anything there. Arranging books in library. Okay, yeah, we can arrange the books in library in the ascending number of pages or descending number of pages. Yeah, definitely. Sorting of mark list in college. Yeah, definitely. When our professors have to create the final list and final rank list basically, so they sort the marks. So there we use the sorting technique. Yeah, these all were very nice examples. One more example that I see is like the words arranged in a dictionary. If you see, all the words are arranged in dictionary are character wise in in alphabetical order. So that's why we can find the words in very fast way. So because of sorting, our searching becomes easy. Okay. So when we like sort out the data, how it helps us? It helps in searching. It helps in searching the things fast. So same way. Uh, I hope I'm audible.
Yes, you are.
Okay, okay. Yeah. So in the same way that we how we see that we can sort the array of integers, but we can also sort the array of characters. Like these were the numbers, but we can sort also A, B, C, D. If we have if we have an array of these characters, even we can sort them too. It's not like that we can only sort the integers, numbers. We can also sort the characters. And because of the sorting of characters, dictionary is based upon. Dictionary sorts these words character wise. That's why we are able to search the words in dictionary very fast. So that was also one real life example where we use the sorting. to make our life easy. Okay, now let's talk about the advantages of sorting. Like one of the advantage I mentioned is searching, like it helps in fast searching. Do you guys know any advantage which will improve our life, like basically makes our life easy? Any advantage that sorting provides? Like we have done the sorting. This was our array 214653, and we perform the sorting. Now our array becomes 1 2 3 4 5 6. But what's its advantage? Why we perform the sorting over here? You should know. If I am performing the sorting, what are its advantages? Why should I perform the sorting here? Anything, guys, in the chat section, please mention any advantage you see. Easy to list out our required things which are sorted. Easy navigation. Definitely, both are correct. Um, it helps us to navigate the things easily. You can, apart from these two things, you can definitely include the searching. Like if I have been given a very long list, okay, of unsorted integers, it will be very hard for me to find an element over there. But if my list is sorted already, then I can perform the binary search over the list and can find the element in a very quick way. So binary search needs sorting. One more thing, visuals. Like when our data is sorted, it is very easy to visualize the data. Suppose if I have a list where multiple integers can be seen. Suppose I have four threes in my list. Then if it will be sorted, then all the threes will be at the same, will be together. So that will be very easy to visualize after the sorting. So these were some advantages that sorting provides to us. I hope they're clear to everyone. Nice. Let's clear it. Yeah. So now let's come to the next point. Yeah. So now let's come to the next point. We should talk about the types of sorting algorithms. So let me tell you, there were some major types which are very popular among the sorting algorithms are bubble sort, insertion sort, selection sort, merge sort, quick sort, and heap sort. These six are very famous. Okay. So out of these six, we will talk about merge sort today. Okay. Today, we will talk about the merge sort, and we will see how it works. We will not see how we have to code it in the computer, but we will see the algorithm behind it, how it works, how it performs sorting so that it makes our list sorted. Okay. So let's start with the merge sort. Mm, mm, okay. Let's take an array of eight numbers. It will be cool. One block, second block, third block, fourth, fifth, sixth. and 7. Okay. Now let's fill some numbers in this. Suppose let's fill 1 to 8 numbers in the jumbled way. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So finally, we have filled this array of size 8 with some integers, and these integers are in random order. They are not sorted yet. Our What is our desired result? We want our array to be like 1, 2, 3, 4, 5, 6, 7, 8 in the sorted form. Okay. So now we will provide this array to our merge sort function, merge sort algorithm. Okay. So now we will see how merge sort algorithm works. Okay. So how merge sort algorithm works is, first of all, it divides the array into two parts. Okay. So the total size of this array is 8. So if we divide it into two parts, then we will have two arrays of size 4 and 4. So this is my first array, and then here is my second array. Till now, we have divided it into two parts. Let's write it again clearly. 4, 5, 1, and 3. Okay. And here we have 8. Oh, sorry. 2, 7, and 6. Oh, now merge sort will again divide it into the two parts, each array. Now I have two arrays of size 4, 4, but it will divide it again. Till Now the question arises, till when it will divide the array? It will divide the array till the size of array becomes 1. Okay. So when I will divide this 4, 1, 5, 3, it will become 4, 5. This one is one array, and second part is 1, 3. Same here. It will divide it into two parts of size 2. 8, 2, 7, 6. What was the condition of merge sort? It will divide the array until the size of the array becomes 1. Does the size of this array is 1? No. So we will still divide it. Now the 4, 5 will divide it into single pieces 4 and 5. This will become 1 and 3. This will become 8 and 2. This will become 7 and 6. Now, till now, I have divided my whole array, this whole array, into 8 parts: 4, 5, 1, 3, 8, 2, 7, 6 separately. Okay. And we will do it using the help of recursion. Like using the recursive calls, we will divide it indefinitely until it becomes the single size array. Okay. So this was the 50% part of merge sort algorithm. The first 50% of part of algorithm is to divide the array until it becomes the single piece. Okay. Now let's see how the rest of the part looks like. Let's use black. Now, till now we were going in the downward direction to divide this array. Now we will go in the up direction to again collect this array, but this time in the sorted manner. Okay. So now I am on this stage and on this pair. So I will check, is 4 greater than, is 4 and 5 are in correct order or not. So I will check, is 4 less than 5? Yeah, 4 less than 5. So I will send the 4 and 5 in the same order how they come. Okay. because 4 is less than 5. Now I will come to this pair. I will see 1 is less than 3. Yeah, 1 is less than 3. So they will also go upwards in the same way 1, 3. Now I will come to this pair 8 and 2. So this time I see that 8 is greater than 2. So I have to replace them. I have to basically change their positions. So when I will go upward, I will not send to 8 2. I will send 2 8. Okay. I just compared 8 with 2. Okay. Because 8 was greater than 2, so I have to switch their positions. Now this will become 2 8. Now let's see this. Again here, 7 is greater than 6. So I will switch their positions and it will become 6 and 7. Okay. Now we are on this level. So I hope you get the point that till now we have this pair 4 5 1 3 2 8 because we changed the positions from 8 to it becomes the 2 8, and from 7 6 it becomes the 6 7. So now you have to focus on these pairs. Again, I have to go in the upward direction. So I have to create this array, this new array with the help of these pairs, these two pairs. So how I will do that? So I will come to this 4. I will come to this 4 and check whether this one is whether this one is greater than 4 or not. Definitely this one is less than 4. So we will switch the positions of 1 and 4. So it will 1 will come here and 4 will come here. Okay. Then I will okay, our pointers were at 4 and 1. Now they switch. So now I will check. I will basically confirm this 5 position with with this left array. So I will check with 5 and 4. But 5 is definitely greater than 4. So again 4 will come here and 5 will come here. After this, I will check the position of 4 with this 3. I'll check this position with 3. And I will find that, yeah, that is less than 4. So here will come my 3 and here will come my 4. And finally, when I will compare 5 with 4, so it will also be switched and the position will become 4 and 5. So my array will become 1, 3, 4, and 5. So this is how, using these two pairs, I will sort this pair into an array of 1, 3, 4, 5. I will do the same with the pair 2, 8, and 6, 7. When I will sort it using these two pointer technique, the sorted array will be 2, 6, 7, and 8. Okay. So now I have two sorted arrays 1, 3, 4, 5, and 2, 6, 7, 8. And now using these two, I have to follow the same order on them and make a new big array that will be sorted. And using when I will use these two arrays to make a new array, my final result will be 1, then here 2, then 3, then 4, 5, 6, 7, 8. So that's how our merge sort algorithm sorts any array. Whatever the array is, it sorts the array in arranging in alphabet. Sorry, in ascending order or descending order. We can use the merge sort array to sort the elements in descending order. Also, we just have to change some few conditions while sorting on the basis of pairs. Okay. So this was how merge sort works. And if we talk about the time complexity and space complexity of a merge sort algorithm, then the time complexity of a merge sort algorithm is n log n. Okay, so this is the time complexity of merge sort algorithm and log n, where n is the number of elements present in the given array. Okay, whereas the time complexity or sorry, the space complexity of the merge sort algorithm is only n, where n is the number of elements present in the array. So basically, if you have an array of size 8, so you will require 8 spaces, 8 size of array to perform the merge sort algorithm. So this is how merge sort algorithm works. Basically, this is the structure. This is the algorithm, how it works. You can find the code for this merge sort algorithm on any website like Geeks for Geeks. So you can find the code here. You can implement it there. But the most important thing is you should have the knowledge how it works. And this is the whole way how merge sort algorithm performs operations and sorts an array in the n log n time complexity and n space complexity. So this was all about the merge sort algorithm. Now let's talk about basically the time complexity and space complexity of all the algorithms uh, that we majorly discusses. Okay, so, so if I tell you what are the major popular algorithms. Quicksort is one major popular algorithm, then merge sort, then heap sort, then these bubble sort, insertion sort, and selection sort, and then counting sort. Okay, so these are the very quite famous algorithms. Even you can, I will share this link. You can check out this link as well. Let me share this in the chat section. Everyone in the meeting. So let's discuss these time complexities and space complexities of the algorithms. Uh, as I told you, there are already so many types of algorithms for sorting. That actually their initial product and final product is same. Their initial product is unsorted array and their final product is a sorted array. But in the middle, how they process it is different. Suppose a merge sort processes in the recursive way, whereas the bubble sort uses the loops to sort an array. So there are quite differences in between them. You can definitely read about them how they processes. Merge sort was the quite famous one. That's why I discussed because most of the interviews ask about the merge sort, how it works. So you can say how you can tell how the recursive code works. And yeah, so let's talk about their time complexities and space complexities. As I told about, the time complexity for the merge sort in best, average, and worst case, all the three cases are same because it is not number dependent. So that's why it has the n log n time complexity in all the cases, whereas the space complexity is big of n. Whereas if we talk about the bubble sort and insertion sort, their average and worst case time complexities are very poor. That is n square, and n square is really a bad number when we talk about the sorting. The good number is n log n or n, that is n plus k. Uh, and n square is quite a bad number because it will perform very poorly when the list is very large. Okay, suppose if I have 10 numbers, if I have 10 numbers in my array, so what will be the square of 10? That will be 100. So I will have to perform 100 operations for sorting an array of size 10 only. Whereas if the size of array becomes 100, it will take 10,000 steps. It will take 10,000 operations to sort an array. So n square grows very rigorously. So that's why it's very poor to use these algorithms. Meanwhile, we have one more algorithm, the counting sort algorithm, that uses the time complexity of n plus k. But it has one disadvantage, that the space complexity will also go to the big of k. That is, you will need the space as equal to the largest number in the array present. So we have as the largest number of the array increases, the size complexity becomes worse. So that's the major disadvantage of counting sort. Otherwise, the time complexity is very nice. So in this chart, green means very good, orange means okayish, orange and yellow means okayish, and red means very poor. Okay, so you can visualize this on that basis. Okay, I hope everyone is till now with me, like they are everyone is understanding what I'm saying. And if you have any doubts, you can ask. Otherwise, we can go to the next topic inside the sort. If you guys have any doubt, you can ask. Feel free to ask any questions related to this topic. Basically, I'm going to give the brief of sorting algorithm. So the thing is like you cannot learn everything in 1 hour session. So you have to do research on your own after this session to learn more about sorting. I will try to cover most of the things, but yeah, definitely you cannot cover everything in 1 hour. So it will be really good if you do the research on your own after this session. What things I have made you learn, or other things also. So if you will learn all these things, it will definitely help you in your coming interviews. Okay, I guess no one have any doubts. So let's go to the next topic inside the sorting. The next topic is in place sorting and not in place sorting. Let me clear this. Let me write in in place and not in place. So yeah, we have in place sorting and not in place sorting. So this is a very popular interview question that many times interview ask to interviews. What is the difference between in place sorting and not in place sorting, and what are the examples of algorithm which uses the in place sorting and which uses not in place sorting? So this is a very confusing question. Like many guys learns about the sorting, but they don't think about what actually this is. So this is just a fancy term. This this is just a fancy term to say, is your algorithm using any extra space or not? Okay. So this is just a common term. You don't have to worry about much. The in-place sorting means, is your array, is your sorting algorithm taking any extra space or not? So if it doesn't take any extra space, if it doesn't take any extra space, then it is in place sorting. And if it takes any extra space, then it is not in place sorting. So as we discussed in the merge sort algorithm, that it is a big of n. big of n sorting algorithm. So that means it takes some extra space. So that's why it is not in place sorting. Okay. We have sortings like bubble sort or like heap sort, bubble sort, insertion sort. Whichever algorithm taking big of one time means it is not taking any extra space. So if we will count that in not in sorry, we will count in place sorting. But all other algorithm which are using O of n, O of n plus k, of log n time, they are not in place sorting because they are using some extra space. Okay. So this was one of the very popular interview question that majorly interviewers ask. Uh, Basically, they checks whether you know about this fancy term or not, in place sorting or not in place sorting. But it is nothing new. You just have to know that which algorithm is taking extra space or not. Then the second popular interview question that comes to my mind is the stability of algorithm. Stability. This is a very interesting thing. Let's discuss this once I write. So what actually is stability of sorting algorithm? So stability means when two or more values maintain the same relative order. Suppose I have an array whose values are 3, 2, 2, 5, 1. So when I will sort this array, my answer will be 1, 2, 2, 3, 5. But we don't know where this 2 goes. Like this is here or this is here. So this is, there comes the point stability. So if both these twos maintains the same relative order in the final product, then they are known as, that algorithm is called the stable algorithm. Otherwise, that algorithm is called the non-stable algorithm. So, uh, if this 2 will remain at this, I means this 2 is, if this 2 comes first in this array, so this 2 should also come first in this array. If that happens, then the algorithm will be stable algorithm. And what are the some common examples of stable algorithm? Insertion sort, bubble sort, they are stable algorithms if they maintain the relative order for the same values. Whereas the merge sort, quick sort, they don't maintain the relative order, they are non-stable algorithms. Now we have discussed two things: in place sorting, out place sorting, and the stability. Now the third question arises: adaptive and non-adaptive sorting. Let me write here. So this is our topic: adaptive and non-adaptive sorting. So what actually it is? So if someone asks what adaptive and non-adaptive sorting is, it's basically if our sorting algorithm make use of already sorted element, then it is called the adaptive algorithm. Okay. Suppose I've been given array 1, 2, 3, 4. Okay. So this array is already sorted. So if any of my algorithm makes use of it, that this array is already sorted, so I will take the less time, then that algorithm will be called the adaptive sorting. Whereas if it doesn't take the advantage of it and do the same thing that it does to the say, all other arrays, then it will be called the non-adaptive sorting. So these three were very important interview questions that can be asked about the sorting, like in place and not in place sorting, stability, and adaptive algorithms. So if you guys have any question till now, you can ask. Any questions you guys have? Don't hesitate in asking questions. You can ask anything related to this topic, obviously. Am I audible now? Nitya, can you please confirm? Am I audible?
Yes, you are audible.
Okay, okay. I thought I'm not audible. Guys, be interactive. Ask some problems if you face any issue. Otherwise, I will understand that you have got the topic clearly. Anything? Okay, let's wait for 2, 3 minutes. Anyone have any question? You can ask. I guess we anyone have no questions. So let's move to a problem we should solve. Uh, one more thing I would like to discuss is that when I was in college, so when I was reading, suppose I read a topic, I got to understand the topic. Then um, what we do is like I always used to solve some problems around it after reading the uh, topic. So if you guys are here are understanding the sorting topic, then I must say that you should solve some problems also. Uh, one question I would like to discuss here is let me clear it. So if this question was related to like I have been given a set of strings and I have to print the anagrams together. Now, what are the anagrams? So, two strings X and Y are called anagrams if we can get a string Y by rearranging the letter of X. So, let me write here. Suppose I have a word which I am denoting with X that consists of A, B, X, Z. Okay. And I have a word Y uh, that constitutes of X, B, A, Z. And I have another word W, Y, X, A, C. Okay. So suppose I've been given these three words and I have to check whether they are how many words are anagrams or not. What is anagram? Anagram are two words. Uh, if we can rearrange the things and make them similar. Okay. So this is also very common interview problem to find the anagrams. So how I will not code the question here, but I will show you what's the way to solve this problem. So basically, I will perform the sorting over the word X. So it will become same A, B, X, Z. Okay. When I will perform the sorting over the Y, it will become A, B, X, and Z. When I will perform the sorting over the W, it will become A, C, X, Y. Okay. So now what I will see is I will just compare all these words with equal all together and will check how many words are equal or not. When I will compare X with Y, I will find that yeah, ABXZ is equal to ABXZ. So I have one pair of anagram. Then I will convert, I will check X and W. So I will see that ABXZ is not equal to ACXY. So I will not get any anagram here. Then I will check Y and W. So ABXZ is not equal to ACXY. So after checking all the words, I get that I have only one anagram that is made up of X and Y, whose values ABXZ and ABXZ. So that's how you find the anagrams. Basically, anagrams is to check whether after the rearranging they are equal or not. So this was the question, and I hope you will be able to code it after the session. So yeah, definitely practice that. And if you have any doubts related to anything, now you can ask. Otherwise, we can wrap up the session. If you don't have any doubts, we can wrap up the session. I guess uh, we don't have any doubts. So, Nitya, can we like wrap up the session?
Yes, we can.
Okay, so I'm stop sharing. Anything anyone wanna ask, still can ask.
I think we are good to go. The session was really very interesting. So thank you so much for coming in and attending the session with the students. They
Yeah,
like I
thank you for the warm welcome.
thank you so much for session. So when I request everyone to please fill the feedback form, and also I want to let you know about the My Gurukul program. So My Gurukul program is basically a job program where we can actually place students free of cost and train them while placement. So you just have to register for it, and then you have to give the test available for the job opening. Once you are done with the test, you have two rounds of interview, one with MyWays, one with our hiring partner, and then you can get placed and trained accordingly. So if you are interested, please go get to register yourself at the MyWays website. The link is in the chat box, and feel free to join our community groups over LinkedIn, WhatsApp, Facebook, and all other social media platform. Thank you so much for joining in today. Thank you so much. Thank you so much, ma'am, once again to teach our students.
Okay. Bye. Bye,
Bye.
guys.
Thank you. Have a lovely weekend. Bye.
You too, and
Thank
everyone.
you.